Hey guys, so in this video I'm going to be start talking about basic electrical circuits and the different types of electrical circuits such as series circuits, parallel circuits, and series parallel circuits, and kind of the characteristics of what's different between them and what goes on throughout them. And now that we're kind of getting into the more detailed circuits I'm going to be talking about now, we're going to be using conventional theory, such as that electricity flows from positive to negative, because that's the one that we use in the automotive world. So our first type of circuit is going to be a series circuit. And a series circuit is basically a circuit where you have one power source and simply one branch for the whole entire electricity to flow, not multiple branches. And in this video, in this circuit, we have right here, we got a basic fuse, then we got a switch and a light bulb, and then the ground circuit. Now, like I said, this is a series circuit, and you only have one branch. So if you end up getting an open anywhere in this circuit, it stops the whole entire flow. And there will be no more electricity flowing because that one open will open the whole circuit. Fuses are obviously made to prevent high current. If for some reason you get a short to ground before the load and you get so much current, the fuse will stop it, protect it, and as usual, switch as you have in any type of circuit. So in automotive circuits we use 12 volts, so this battery is essentially 12 volts. And the way that voltage pretty much acts in a basic series circuit is you will always have your source voltage, your available 12 volts. It'll flow throughout the circuit, so once this switch closes, that voltage will flow through the fuse, to the switch, and to the light bulb. Then once you get to the load, it'll drop all of the voltage as long as you have one load in that. So right here you'll have your source voltage, a voltage drop of 12 volts. If you have multiple light bulbs throughout the circuit and it's still a series circuit, and so if I say to put one bulb right there, then the voltage will evenly drop throughout those ones if they're the same bulbs. So you may have 12 volts drop on the first bulb, and 6 volts drop on the first bulb, and then another 6 volts drop on the second bulb. Unless, say, maybe the first bulb is a very bright one and the second one's a very small one, then you may get maybe a 10 volt drop at the first one and only 2 volts drop at the second one. But from power to ground, you should always have your full 12 volt drop in a series circuit. Also, in a series circuit, your current, since you only have one branch, your current is going to be the same throughout the whole circuit because it's your one and only branch. So basically with the series circuit, again as I stated, you basically have one source voltage, you have one set of current, and you have a total resistance of the whole branch. So now we have our next set of circuits, which is parallel circuits. Characteristics of what happens and goes on in them is a little bit different from a series circuit. But basically what makes a difference is now, instead of having only one path for your current to flow, you have multiple branches. And that's what you have in a lot of automotive circuits, especially light bulbs. They may work off of some of the same power, maybe sometimes even the same fuse or switch, but they have multiple branches for each bulb. And this example I have here, I have a resistor of 12 ohms. This one I have a little light bulb of 6 ohms. And this one I have another resistor of 8 ohms. And like a series circuit, you have your 12 volts that goes through the fuse and then the switch once it's completed. And all 12 volts goes off equally to each branch. So at the beginning of each one of these circuits, I will have 12 volts available to each one. And again, that 12 volts will drop across each one. So after it, on the ground side of each load, you will then have 0 volts. Unless you add another, say for example in this circuit you add another resistor, then depending on the resistance of the two resistors, you'll have some voltage drop across one and some voltage drop across another. But if you just have one light bulb, you'll get that full 12 volt drop on that one bulb. Now, some of the positives of why we use parallel branches is that if you get an open somewhere, depending on where the open is, it may only cause just one of the branches to go out. So if, say for example, you have this bad resistor, this resistor goes out and it creates an open in that resistor, only this circuit will now be inoperative. These two, however, will still be able to work because they have their available voltage. Now if you get up here to the power side and something happens to the switch, or say in this case this fuse blows, then you will lose all your power to each and every one of the branches. Also, another unique thing that makes a difference in a parallel circuit compared to a series circuit is that the current will be different in each branch. So, and that's dependent on the resistor. So this branch you may have maybe 2 amps of current. This one you may have 4 amps of current, and this one you may have 5 amps of current. That's what makes, again, different in a parallel circuit. You can have different currents depending on the resistance and the voltage that you have available to it. So another unique kind of thing about parallel circuits is that the overall resistance of the whole path and the whole circuit is always less than the lowest branch that has the least amount of resistance. So in this case, for example, our least amount of resistance is this light bulb. It has 6 ohms. So that means that the overall circuit resistance is actually less than 6 ohms. And it can be kind of confusing, but you can kind of look at it as basically the more current you have flowing, in order to have more current flowing overall, you have to have less resistance. It can kind of be confusing, but that's just one of the characteristics of parallel circuits. And then one last thing about parallel circuits is that total current, to figure out what total current is throughout the whole circuit, is basically the sum of all the current in each branches. So once you calculate, obviously we know we have 12 volts and you have these different types of resistors that determine your current. Let's just say for a quick example, this one has 1 amp, this one has 2 amps, and this one has 3 amps. Then that means your overall current throughout this whole circuit is 6 amps of current. Then we have our other set of circuits, which is series parallel circuits. And really it's the same exact thing as a parallel circuit. The only difference is that you add a resistor up here before the voltage spreads out. So if I add a resistor right here, that now takes up some of the available voltage. So let's say that across that resistor we end up losing 2 volts. Now to each one of these 3 branches you now have 10 volts available because some of that voltage got used up right there at that resistor before it went to these different branches. And so this resistor is lined up in series with this overall parallel circuit. And other than that, everything else is basically the same characteristics of a parallel circuit. Just the only difference is you have one resistor before it. One last thing about circuits that is a big misconception to a lot of people is the old saying that current takes the path of least resistance, and that is absolutely 100% false. In this basic example here, I have 3 different branches, and each one has 3 different amounts of resistance to it. But let's say, for example, they're all bulbs, they're all going to light up, aren't they? If that saying was true, then only this bulb will light up because that's the one with the least amount of resistance. That's simply not true. Current will still take each and every path. Now, what is kind of true of that is current takes the path of no resistance. So if I somehow get a short to ground, say up here, and it goes right there, then all these circuits will then stop working because almost all that current is going to go right there, provided that, we'll say it's no longer this, it's just a regular circuit. So now, once you complete the switch, all of that current will flow to this short to ground because there's no resistance. And even then, at the kind of the microscopic level, some of those, as I said before, that electricity is full of electrons. Even then, with that short to ground, you will still get a couple electrons flowing to each one of these different branches, but it's not going to be enough to light those bulbs up. So that saying, current takes the path of least resistance, is definitely not true. Because like I said, you're always going to have multiple branches, and they're all still going to be working. That's all for this one, the characteristics of the different types of circuits. Hope that helped. Thanks for watching.